Okay, so I'm just going to go through and provide a guide for answering all of the questions on the WebWork, although I am going to change all of the numbers so that you guys will have to do something. We're not supposed to just give you guys the answers. So I just changed the point here, and I'm still going to go through and solve it just with this new point. So if we've got the XY plane, that tells us that Z is equal to 0, which means that we can set our X and our Y values to anything that we want. And the value that's going to minimize that is if we just set it to be equal, have the same X and Y values as these points. So, and you can kind of see, like, if I do this, that's going to be a bigger distance than if I do one that's right below it. So give you a nice little visual argument there. So then we set X equal to 5, Y equal to -12, and then Z still has to be equal to 0 because it's on the XY plane. So if we do the square root, we just plug this into the distance formula, so that's going to be x1 minus x2 squared, the square root of x1 minus x2 squared minus y1 minus y2 plus y1 minus y2 squared plus z1 minus z2 squared. That's our distance formula, right? So if we plug that in here, we get the square root of 5 minus 5 squared plus -12 plus, double negative, so minus -12 becomes plus 12 squared plus -13 minus 0 squared. This is 0, this is 0, and we get that is equal to the square root of 13 squared, which is just 13. So this right here is 13. And that is also going to, if you notice 13, -13, it's, for these guys, it's going to be the same thing as if you just had a distance on a number line, which is just the absolute value of X, because we're doing the distance from 0 to this thing, which is always going to be that thing, the square root of that thing squared, which is just its absolute value. So save us some time on these two. This is just going to be the absolute value of 5. So that's 5. And this is going to be the absolute value of 12, or of -12, which is just 12. So if you do this when it's only going to be, your X and your Y values are the same, then these are going to zero out, and then you're just going to have 0 minus this thing squared. That's square rooted, which again is just the same as the absolute value. So now, oh, oopsies. Erase too much. So we did 5, -12, -13. So here we have y is equal to 0, x is equal to 0, y is equal to 0, z is equal to 0, but we can still pick our x to be anything. And again, that's going to be minimized when x is just equal, the x value of our point on the x-axis is just going to be equal to the x value of our point, our given point. So here we're going to try to find that point that'll minimize that. So that'll be 5, 0, 0. And the distance is going to be square root of 5 minus 5 squared plus, which of course zeroes out, -12 minus 0 squared plus -13 minus 0 squared is equal to the square root of 144 plus 169 And you can just solve it from there. This is not going to simplify nicely, sadly. So this one, though, if this one we have the x and the z. So here we have our y we can set to be the same. So this will be 0, -12, 0. And distance here going to be the square root of 5 minus 0 squared plus that thing zeroes out in the middle, plus -13 minus 0 squared. And this is going to be equal to the square root of 25 plus 169, which is going to be the square root of 184, which is not going to simplify any nicer. This is going to be 144. So you can just leave it like that. This last one will actually simplify pretty nicely. So this last one will be x is going to be equal to 0 again. So we get 0, 0, -13 is the point that is on this. That's going to be closest to our given point. And therefore, we're going to do 5 minus 0 squared plus -12 minus 0 squared is equal to the square root of 25 plus 144, which is the square root of 169, which is equal to 13. So that is how you find all of these distances. Again, you're going to have a different point, but this is the exact system that you will go through to solve it. Okay, so again, I'm going to have to change our constants, change our values a little bit. Sorry, this should be 24. Should be 24. So instead, we're going to do x squared plus y squared plus z squared minus 6x plus 8z is equal to 24. And how are we going to do this? Well, we're going to start off by completing the square. So I have x squared, and that's 6x, and that's z squared, and that 8z. So how am I going to complete the square? Well, I'm going to change this to x squared minus 6x, and then I do this divided by 2 and squared, and I add that to both sides. So this is equal to 9 plus 9 plus 9 plus z squared plus 8z. And the 8z, I'm going to do the same thing. So that's 8 divided by 2 squared. So 8 divided by 2 is 4, squared is 16. So plus 16 plus 16. And then plus, should do plus 9 plus 16 here. To keep it balanced on both sides. Plus y squared is now equal to 24 plus 16 is 40 plus 9 is 49. So I'm just going to erase these to make some room. Now we have the radius of the sphere, because it's going to be, this right here is going to be x minus 3, because it's the value that we had here of the -6 divided by 2 is going to be -3 squared plus y squared plus z plus the 8 divided by 2 is 4. Z plus 4 squared is equal to 49 which is equal to the radius squared. So 49 is 7 squared. So our radius is 7. And what is our center? Well, we have x minus x naught. So that means the x value is going to be 3. The y value is going to be 0 because y minus y naught, just y squared is the same thing as y minus 0 squared. And then the z plus 4 is going to be negative 4. So that gives you the sphere here. Okay, so again, changing our values. So I'm going to do our u and our v are defined up here, not the ones that are here. So u plus v is just, I add them component-wise. So I have negative 2 plus 2. So that becomes negative 2 plus 2. In my x direction, negative 3, or 3 plus negative 3, and 5 plus 4. So that is going to, this is 0, and this last one is 9. So we get 0, 0, 9. U minus v is the same basic idea, but so we have u minus v, and of course now the order matters, where the order didn't really matter. So we have negative 2 minus 2, 3 minus negative 3, and then 5 minus 4. So this is going to become negative 4 in the x direction, positive 6 in the y direction, and 1 in the z direction. Now we'll have 2 minus negative 2, negative 3 minus 3, and 4 minus 5, which is going to be equal to positive 4, negative 6, negative 1. And if you notice, this and this are just negatives of each other, right? And that's just because if you multiply this whole thing by negative 1, what do you get? Well, you get this, right? So if you solve this, you can just switch the signs on everything to get this. Save yourself a little bit of time. 3u, we just multiply all the components by 3. So we do 3 times the negative 2, 3 times the 3, and 3 times the 5. So that becomes negative 6, 9, 15. Same idea here, just we're multiplying by negative 1/6, and we're doing it here. So we get, that's negative 2 divided by 6. Negative times negative 3 becomes positive 3 divided by 6, and then negative 4 divided by 6, which of course simplifies to negative 1/3, positive 1/2, and negative 2/3. Cool. So now this last one I'm just going to do off by the side because it'll take a little bit more space. I have to do 5 times u and 6 times v first. All right, you could just do throughout, but I'm going to do them first. So that becomes, you could do it as a single expression of 5 times your x component minus 6 times your vx component, but I'm just going to do them out first. So 5u minus 6v is going to be equal to, that becomes negative 10, 15, 25, minus 6 times v, so that's going to be 12, negative 18, 24. So now that minus that is going to be negative 10 minus 12 is negative 22. 15 minus negative 18 is 15 plus 18 is 33. And then 25 minus 24 is 1. So that is your answer right there. Okay, so now we're going to, again, try to figure out if these values are parallel, but again, I switched the value. So first off, what does this even look like? So if we have the vector AB, well, that's going to be, so 0, 1 is right here, and 3, 4 is going to be here. So it is this arrow that goes from A to B. So how do you figure out whether these are parallel or not? Well, first, let's just kind of figure out numerically what these are. So AB is going to be the same value as the point B minus the point A. So that's going to be the x value of B minus the x value of A. So it's going to be 3 minus 0. And then the y value of B minus the y value of A. So that's 4 minus 1 is equal to 3, 3. And then do the same thing with PQ. So that's going to be Q minus P. So that's going to be 2 minus 4. And then 0 minus 2. So that is negative 2, negative 2. So they're parallel if they are a scalar multiple of each other. And these are going to be a scalar multiple of each other. So to get from this to this, I would just multiply by negative 3 over 2 to get here. Negative 3 over 2. And the opposite direction, you do negative 2/3. But they are just scalar multiples of each other. So that tells me that they are parallel. If they're not scalar multiples, then they're not parallel. And if they're pointing in the same direction, is if they have the same sign attached to all of their components, and they're parallel. If they're not parallel, then they won't be pointing in the same direction. So here we have 3 and 3, which are both positive. Here they're both negative. Therefore, pretty clearly, they're not pointing in the same direction. Okay, again, just changing most of the constants, or most of the numbers here. I'm actually just going to leave this here, just save a little bit of space, rewriting things, but it also won't actually affect it because you're dealing with a completely different vector. So first off, I have to figure out what this vector v is. So I'm going to subtract the endpoint from this, subtract the start point from the endpoint. So then v is equal to 7 minus 2, 2 minus negative 3, and then 6 minus 2. So v is going to be equal to 5, 5, 2. So that gives me the vector here. And what's the length of this vector? Well, it's going to be just the same thing as that distance formula. So it's going to be the magnitude of v is going to be equal to the square root of 5 squared, 5 squared plus 5 squared plus 2 squared. And I'm just going to rewrite a few of these things to make them clearer. And that is equal to the square root of 54. So square root of 54. That does not simplify to anything nicer than that. So if the tail of, you could pull out a little bit, but it's not going to be worth your simplification. This is also equal to 3 times, if I pull out the 9, I am left with 6. 3 root 6. But you don't have to simplify. This is perfectly fine right here. So if the tail is at this point, well, then I just add this vector to that to get the tip. So that becomes -5 plus 5 plus 5 plus 2. So that gives me the point 0, 0, 1. Again, this is a point, not a vector, but gives you that point right there. If the tail is at -1, -1, 7, -1, sorry, the tip is at -1, 7, -1, then I subtract the vector from that to get the tail. So if I'm starting with the tail, I don't want the tip, I add it. If I'm starting with the tip, I don't want the tail, I subtract it. So -5, 5, 2 will give me -1 minus 5 is -6. 7 minus 5 is 2. -1 minus 2 is -3. Cool. So what is a vector that has the same length, points in the opposite direction? Well, that's just going to be the negative of this. So it will have the same, if I just multiply by -1, that'll preserve the length, but it will point in the opposite direction. So that'll be -5, -5, -2. And then the vector that has the same direction but is twice as long, I'm just taking this and multiplying by 2. So that's going to be 10, 10, 4. And if you want, you can check that if you multiply this by 2, then the magnitude also just scales by 2. But that should be pretty easy to check using this distance formula definition. Okay, so again, changing the constants here. So we want to find the unit vector in the same direction as this. So how do we find the unit vector? Well, the unit vector is just going to be the vector divided by its norm. So this is going to be 512 divided by, what's the norm of 512? So the norm of 512 is going to equal to the square root of 25, 5 squared, plus 12 squared. So that's going to be 144. It's equal to the square root of 169 is equal to 13. So divide by 13. So this is going to be 5 divided by 13, comma 12 divided by 13. And just a heads up, it will be good for you guys to be able to recognize at least some of the more common Pythagorean triples, which are these, the numbers that when you square them and add their squares, add up to another perfect square. So if you like draw it out as a triangle, a right triangle, then all of the sides are going to have integer values, which you get here with 5, 12, 13. You also get it for 3, 4, 5 is the most well-known one. So that will be useful for you guys to recognize. You can calculate them otherwise, but it'll save you time. So and it's pointing in the same direction, so we don't have to multiply by -1. Here, it's pointing in the opposite direction, so in the end, we will have to multiply by -1. But first, we have to find the norm of this, right? So that's going to be the square root of, so the norm of v here is going to be the square root of 3 squared plus -4 squared plus 12 squared. So that's equal to square root of 9 plus 16 plus 144. So that is, again, the square root of 169, which is 13. So now the v divided by the norm of v, but again, we have to multiply by -1. So what will that be? Well, that'll be equal to negative times 3i is going to be -3 divided by 13. 4j, so sorry, -4j becomes +4. Again, divide by 13 though. And then 12 becomes -12, divide by 13. Or if you prefer to keep it in the IJK notation, then we get -3 over 13i plus 4 over 13j minus 12 over 13k. Really the only reason to ever prefer the IJK notation is it makes the cross products nicer to deal with. But other than that, I would suggest you use this. But I do know a lot of students prefer the IJK notation. You will not be penalized for that. You can use it all you want. I'm just going to change color here so it's clear what's what. Okay, so now we want the unit vector that has the same direction as the vector from A to B. So that means that we have AB is going to be equal to B minus A, right? So that's going to be equal to 2 minus -2 in the X component, and then 4 minus 1 in the Y component. So that is equal to 4, 3. And we want a unit vector that has the same direction as this. So we want just to divide this by its norm. So that becomes, this is the norm of AB, or the magnitude of AB. However you want to say it, they're the same thing, is equal to the square root of 16 plus 9. The square root of 25 is 5. So we just take 4, divide by 5, and 3 and divide by 5. So again, I set this up so that there was basically all Pythagorean triples because they're nicer to deal with than nasty little square roots, but that's how you solve it. So here we're just going to find a vector that has the same direction as this new vector, but has length 4. It's not going to be a pretty number, but we'll figure it out. So that is equal to, so that the magnitude of our starting vector, right? So first we have to do, this is v. We have to find the magnitude of v. So that's going to be equal to the square root of 49 plus 64 plus 169. So let's figure out what that is. So that'll be equal to the 9 plus the 9 becomes 178. That's the square root of 218 plus 64. 4 plus 8 gives us the square root of 282. So that is our magnitude. So, but we don't want it to be that. We want it to be 4. So how are we going to scale it? Well, we're going to divide by this and multiply by 4. So if we divide by this, that gives us a unit vector. So it has length 1. If we multiply by 4, then it gets back to having 4 as its length. So we do v times 4 divided by square root of 282 is going to be equal to 28 divided by the square root of 282, comma, -32 divided by the square root of 282, comma, the 52 divided by the square root of 282. So same basic idea of you find the magnitude, you divide by the magnitude and you multiply by the length that you want it to be. And it has the same direction, so you don't have to worry about multiplying by -1, but if it asks for the opposite direction, you would have to multiply by -1.